Hi, how are you doing?
Hi, sir. I'm fine.
Uh, so we were studying work and energy, right?
Yes, sir.
So what about others? They are not getting interest in class or whatever? So can you tell me what is, okay, Riaz. Hi, Riaz. Hi, Riaz, how are you doing? How are you doing? So will you tell me what
Fine,
is,
sir.
will you tell me what is work? Can you tell me what is work? What is energy? You don't know what is work and what is energy? Uh, Work is if you apply a force F. Good. When you will apply a force on an object F on an object of mass, object of mass M. Okay. When you apply a force F on an object of mass M and get a displacement D and get a displacement T. So what does it mean mathematically? This is an object of unit mass, right? Unit mass, and you applying it 1 Newton force on it, 1 Newton force on it, right? And this object gets a displacement of unit length, a displacement of unit length. So what it will be? It will be F dot D unit displacement, a small displacement, or write like that, F. This is dot product, okay. F into displacement, force into displacement, force into dot product, displacement. This results in work, right? Did you get? Did you get it or not? So now I'm asking you a few questions. Now I'm asking few questions, right? So this is a block. This is a block, right? Of mass 1 kilogram. And we made 1 meter of displacement applying a force F. So what will be the work done? So work done will be force into displacement. The force will be what? M. Suppose this is acceleration. We are giving acceleration to it. Acceleration. We are providing acceleration to this object. Okay, unit acceleration. So this will be mass time acceleration into displacement. Further, if you will write the same, F into S. Clear? Now, I'm asking you another question. This is again 1 kg block. And instead, acceleration is in this direction. Displacement is in this direction. This DSPLACEMENT displacement is in this direction and force is in this direction. And force is in this direction. So what will be the work done? So tell me what will be the work done. What will be the work done? Are you there? Why are you not responding? You on the camera. Everyone kindly on the camera. Why you are not responding? Why are you not responding? On the camera. On the camera. Shama, you are new one. On the camera. Jabbar on the camera. Riaz on the camera. Rumaiza on the camera. My point is displacement is in this direction and force is on the perpendicular to the displacement. So what will be the work done? Tell me what will be the work done.
So if force and displacement are perpendicular to each other,
Yeah.
0.
Okay. So this will be F S cos 90 degree. The angle between these two is 90 degree, right? 90 degree. So if I will draw the free body diagram, that's force displacement is force is in this direction and displacement is in this direction. So these 90 degrees. So this will be cos 90 is how much? Cos 90 is how much? Remember, cos 90 is how much? What is the value of cos 90? Cos 90 is equal to how much? Riaz, what is the value of cos 90? I think you studied trigonometry in class 9 little bit, right? I think you guys have studied trigonometry in class 9 as well. This class hardly respond. I don't know what to do. This class hardly respond. I don't know what to do. Cos 90 is 0. Cos 90 is 0. Oh. What is sine 90? What is sine 90?
Sir, we didn't learn about
Hmm?
sin
What
and
is
cos.
sine 90 is what?
We didn't learn about this, sir.
You didn't. I think you mean even in the class 8 there are some part, or even in the 9 there is some trigonometry. Okay, so keep these two value. Now I'm asking you a question. Not much work spite of working hard. Is there some situation where you are working but there is no work is being been done? You are working, okay, you are exhausting yourself, but in the sense of physics there is no work done. You, such thing happens, is possibilities of that. Suppose this is a wall. This is a wall. This is a wall. And you are pressing it. And you are pressing it. Is there any work done? Is there any work done? You are pressing a wall, right? You are pressing a wall. This wall is already wall of your home, and you are pushing one of the wall. So is there will be any work done? Riyaz, Jabbar, is there will be any work done? You are pressing a wall, right? And there is no displacement in wall. If you will press a wall, there will be no displacement at all. So if there is no displacement, displacement is zero. So force into displacement, force into zero, then work done is zero. Right? I'm audible? I'm audible or not? No, you have to respond. Unless until you won't respond, I won't move further. You have to respond.
Yes, sir.
So I'm saying that if you are pushing a wall, okay, you are pushing a wall, there will be any work done? Riyaz, there will
No,
be any
sir.
work done? No, why?
Because displacement is zero.
Okay, displacement is zero. So one is the case that when force and displacement is perpendicular, the force and displacement is perpendicular, where F is force, F is equal to force, and S is displacement. S is displacement. Displacement, right? And another thing is that if there is no displacement on application of force, if there is no displacement, this PLA, PLACE, displacement, if there is no displacement on application of force. Application of. Is there any other situation where there will be no work done? Riyaz, is there any other situation where there will be no work done? Okay. If you want respond, then solve this numerical.
Sir, can you repeat?
Solve this question.
So this is like potential energy and that one.
Yes, yes, yes. Take the consideration of that. So it is like this is ground, okay, and a porter is, this is box, whatever it is, and he is pulling it to 1.5 meter, okay. So in this case, what will be, the box is 15 kg and height is 1.5. So what will be the work done? So this is situation like, now block is at 1.5 meter above the ground. It is 1.5 meter above the ground. And this is 15 kg. We already studied about the weight, right? So weight, W-E-I-G-H-T, weight. That is mass time acceleration due to gravity, right? So this is equal to force. This is equal to force for the given problem. Okay, and you have displacement of 1.5 meter.
Sir, for this potential energy, sir,
Uh-huh. Yeah,
this is potential energy, right?
this is weight. Is, if box is over some particular height, so there must be a potential energy, of course.
So
There
weight
must be
equal
a,
to mg is that one.
there must be a potential energy. Okay, force into displacement. So work done will be stored in potential energy. Work done will be stored in, potential energy. Potential energy, right? Got the point or not? It's clear? No doubt. So now put the value of the parameters or parameters and calculate the work done. Put the mass, acceleration due to gravity, and height. Yes, did you get the meaning? If this is object and we are raising it to a height, okay, so the work done will be equal to the change in potential energy, right? So the change in potential energy is mgh. So just substitute the value of mg and h, you will get the work done.
Sir, we have mass and then we have height.
Yes,
What
we
is
have
g, sir?
mass, and we have height.
Ma'am,
Puts
g.
it
Sir, g is
on his head. So head means that here. So if I am 1.5 meter, so I will raise the object and put over here. So that is the height. You guys are supposed to answer this question. You guys are supposed to answer this question.
22.5.
Okay, let me check. Mass is 15 kg and G is just 10 meter per second, right? And
So
this is
you have to
1.5.
use the this thing only.
Sorry?
9.8, right? G.
So 9.8, you may put it 10. So 225, 15 physical, 225, right? What will be the unit of it? What is the unit of work done?
Sir, work done.
Mm-hmm.
Newton.
Newton meter. This is Newton, right? This much is Newton and this is meter. So this is Newton meter. Newton meter. Clear? Riaz, did you get?
Yes, sir.
Okay. So it was the simplest question. So if you understood this question, then why not this? Try this question. This example has answer as well. Can you do? This is not the part. This is somehow the answer only. This is answer only. What did you get the answer? What is the answer for this?
So we have to find work.
Yes.
10.
Okay, 10. So this is nothing but work is force into displacement. Force into displacement. So force is nothing but 10 Newton, sorry, 5 Newton, and displacement is 2 Newton, right? So this is a 10 Newton meter, 10 Newton meter. And Newton meter is also called joule. Okay, so work has the unit of joule. Clear? Any doubt? Now tell me, what is energy? What is energy?
Sir, it is a capacity of doing work.
Okay, it's the capacity of doing work. Okay. So have you heard about the kinetic energy? Kinetic energy. And what else? Potential energy.
Heat energy,
Okay, heat energy.
light energy.
Heat energy. Okay, what do you mean by heat energy?
Sir, the heat produced by an object during work.
Okay, so you may say that if you are heating an object like that, then light energy. What do you mean by light energy? Light energy. What do you mean by light energy?
Basically, the light produced by an object during work.
So how light produce energy? When you
Light.
play with a simple lens, right? Simple lens, magnifying lens, right? And you focus the sunlight, and put a piece of paper over here, paper. So when light focused at one point, okay, the paper gets burned, right? That's the light energy, one of the form of light energy. Clear? Another is nuclear energy. Have you heard about nuclear energy? Nuclear energy. Riaz, have you heard about nuclear energy?
Yes, sir.
Hmm? No.
Yes, sir.
Nuclear power plant? You never heard about nuclear power plant? Okay. Iran is always in the news for its uranium enrichment. Have you heard? Iran is always in the news for uranium enrichment. So by enriching the uranium, we get nuclear energy, and that's a huge amount of energy. So this is the guy, James Prescott Joule. He was an outstanding British physicist. He is known for his research in electricity and thermodynamic. Amongst other things, he formulated a law of heating effect of electric current. You will read this in the class 10th, heating effect of electric current. It means that have you seen the toaster, electric iron, or laundry, or what I say, geyser? Have you seen this apparatus? Have you seen these apparatus? So when electric current is passed in some gadgets, okay, electric current is being passed in some gadgets due to high resistivity, some of the current is being converted into the heat. Okay, some of the current will be converted into heat. So it is called heating effect of electric current. He also verified experimentally that law of conservation of energy and discovered the value of mechanical equivalent. Law of conservation of energy. What is the law of conservation of energy? What is law of conservation of energy? Law of conservation of energy. You all must knowing what is conservation of energy. Very famous saying. Energy can neither be generated nor created. It's only transformed from one form to other form, right? You have heard about that energy can neither be generated nor be destroyed. It's only transformed from one form to other form. Like if we are heating the this pot, it's a water, right? Water, and you are heating it. This is a flame, right? So we are giving it the heat energy, and water gets boil, right? When the heat energy and the water get boiled. So this is called the conservation of energy. Clear what is conservation of energy? Did you get what is conservation of energy? We will explore it in detail in the coming section, right? We will explore this in the detail in the coming section. So now I'm giving you a situation. This is the situation. So this is a box. This is a plate. Okay. This is a plate. On that plate, we have a weight M, right? We have the weight M. So if we do that, so what will happen? If we will hang this object, what will happen? So if it is at h height from the ground, okay, h height, so there will be potential energy, mgh. So there will be a potential energy. Potential energy, right? Suppose acceleration of this block is 0. A is acceleration. Okay, A is acceleration. A is acceleration. A is acceleration. So if acceleration of the block is 0, so we will find that this will be the potential energy, right? Clear? Any doubt? And this potential energy will be balanced by this block systems, right? This block system will hold this object fixed. Now what we do, we just give a little force to it. Now acceleration is in this direction. So now as we will give the acceleration is change in velocity. A is v minus u by t, right? So as we will give it acceleration, means that it will change its velocity. So as you will change the velocity, so this potential energy will change, and this block will get half of mv square, that is kinetic energy. Kinetic energy, kinetic energy, right? So if I'll say this is point A and this is point B, so total energy at A, total energy at A equal to total energy at B. Clear? This is called the conservation of energy. Any doubt?
No, sir.
Okay. So total energy at A will be kinetic plus potential energy. Total energy will be kinetic energy plus P is potential energy at A is equal to kinetic energy plus potential energy at B. Clear? So at A there is the change in potential energy at B will make a change in kinetic energy at A, right? Any doubt? Any doubt?
No, sir.
So now we have this equation. This is very familiar equation. So what I'm doing, I'm just multiplying it with half m v square minus half m u square is equal to half m a s twice m a s. Clear? So this is kinetic energy. Half of mvi is kinetic energy. This is kinetic energy. This is kinetic energy, final kinetic energy, and this is initial kinetic energy, right? This is equal to what? F m f into s, where ma is what? Force. So change in kinetic energy. Oh, this is kinetic energy. So change in kinetic energy, change in kinetic energy is equal to work done. This is work energy theorem called work energy theorem. Work energy theorem, right? Any doubt? Any doubt to it? Did you understand this concept? Take the screenshot if you wish. Let me see if we have any problem. Keeping this in mind, solve this question. What happened? Oh, 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 oh. That's why now it's went beyond it limit. Sorry, my apology. Give me a second. Now this question is visible. Solve this question. Solve this question. These two questions. Kindly proceed. These are two simple questions. So I hope that you will do it.
Sir, first one is 120.
Yeah, 120. Okay,
Yes.
what is being asked? Kinetic
Kinetic
energy, right?
energy.
So
Yes.
kinetic energy is
Half mv square.
half of m v square. So half time 15 time 4 square. So this is half into 16, 120, right?
Can you share the next one?
120, what will be that unit of it? This is energy, na?
Yes, sir.
So what will be the unit of it?
Sir, unit will be same Newton.
Newton is the unit of force. This is energy, and energy has unit of joule.
J.
Clear? Okay, so This will be the last question of the day. The work energy theorem. It is nothing but from the work energy theorem. Work energy theorem. Energy theorem. We just derive it. What happened? Any progress? Any progress or not? What is work energy theorem? Just tell me. What is work energy theorem? Just tell me.
So we haven't learned that.
Yeah. What is work energy theorem?
So we haven't learned that.
Huh?
We haven't learned the
Oh
word.
my gosh. Yeah. What is this? This is called work energy theorem, right? This side kinetic energy is energy, and this F dot S is work. So work energy theorem. Did you get the or not? This is work energy theorem, man. Change in kinetic energy is equal to work done. This is called work energy theorem.
Okay, sir.
Okay, so now use this concept. Change in kinetic energy is equal to work done. So this is nothing but work done is equal to
Certainly wait.
अच्छा ठीक है. Okay, I'll wait. Okay, I'll wait. I'll wait.